Here in this section, we're going to go ahead and look at the idea of limits and limits in their applications as far as business and real life type of situations. And so in general, what is it? What is a limit? And what the limit is the value of y that a function approaches as x approaches a certain value. So as x approaches a certain number, what is the y value that that function produces? Okay, and for our notation, we use this thing called limit notation, and you'll see the word lim for limit, and whatever variable that your function represents, in this case it's f of x. And you're going to have the value of x as it approaches a certain value a. And this a, it could be a number, it could be infinity, and we're going to talk about all those things in this section. And when a is just approaching a value that doesn't say plus or minus, it's also known as a two-sided limit. And so we want to know what happens with this value as this function approaches this number or value a from the left and from the right if applicable. Right? And so we look at this idea of one-sided limits, and a left-sided limit approaches this number a, this value, from the left-hand side. So as we come from the left and come toward a certain number, we want to see the behavior of that graph as x approaches that number and what the y value is. And the opposite for the right-handed. If it's a right-handed value, that means we're approaching from the right hand side to a, and the a will have this plus on it, and we want to see the behavior as x approaches that value from the right hand side and see if it produces the same value. A limit exists if and only if the limits from the left and the limits from the right are equal to each other. In other words, they match. Otherwise, that limit is something that we say does not exist, or DNE. So they have to match from both the left side and the right side. So the limit exists if it is equal to the left, which is equal to the right. Okay. Here's kind of an example of this. So we're looking at this graph here, and we want to know the limit as x approaches a, and this value a is going to be 0 from the left-hand side as well as from the right-hand side. Well, as we go ahead and approach 0 from the left-hand side, we end up at a value of -1. If we go ahead and look at the limit as we approach from the right-hand side, here we go over and over and over again, and as we approach 0, an x value of 0, our y value is actually 2. So in this case, we have to say that the limit does not exist, since both sides are not equal. You'll a lot of times see the term DNE, which does not exist. You could also write does not exist. That's perfectly okay. All right. So the limit only determines the value of y as x actually approaches a number. X does not necessarily have to be able to equal the value of a. All right. So if we look right here, if we look at the left-hand side, and we're approaching 0 from the left-hand side here, but we can see we have an open hole here, which means that value of 0 does not actually exist. But the closer that x actually gets to 0 from that side, it gets closer and closer to the y value of -1. And that's what we're looking for. So even though that x value actually does not exist at that point, it still is approaching a value of -1. Okay, so you could have an asymptote here. You could have a hole like we just had above that I showed you. And that limit can still exist. So even if a hole or an asymptote is there, that value at a can still exist. The limit can still exist. Let's look at another value here. All right. So if we go ahead and look at this graph here, we notice that we go ahead and approach x to 0. And if we come from the left and go all the way towards 0, even though 0 is not defined, our value from the left also approaches 0. If we come from the right-hand side and approach 0 from the right-hand side, even though that value does not exist, we are still approaching the same value as 0. So the limit from both sides exists and its value is 0, even though x at 0 is not defined. All right. Now, if we go ahead and look at 2, if we approach 2 from the left-hand side, we end up with a value of 2. All right, or a value. We don't have a value here. And if we go ahead and approach it from the left-hand side and approach x equals 2, it's not defined there, but it's also a different value. It's a positive value that's not actually listed here. So this value at x does not exist. This limit does not exist. It's just because of the jump and the difference in the y values, not the fact that that x value does not exist. All right, so we can go ahead and compute limits in 3 ways. Graphically, it's always easy if we see a graph, especially if it's a nice piecewise graph drawn for us. We could go ahead and look at the limit in that direction. But we can also go ahead and use a table of values, and you're going to need a TI-84 to go ahead and do this. And we could go ahead and mathematically calculate the value that y approaches and see if our value exists from the left and from the right. And then we can also go ahead and compute a limit algebraically, which we're going to do at the end of this section. Okay, so let's go ahead and look at a value of limits. And here we want to go ahead and look at the limit as x approaches 1. Now, this is from both sides because it's a regular limit of this function x. All right, and our function is defined as 2x squared minus 4x plus 7. All right, and what we want to do is we want to use the table feature on a graphing calculator to go ahead and help us with this. So the first thing we want to do is go into your y equals on your calculator, which will go ahead and be on the upper left-hand side, gray key. All right, you're going to go ahead and hit that, and you're going to go ahead and input that function into your calculator. All right. Once you go ahead and get that in there, you're going to go ahead and hit the second and window to go ahead and hit the table settings. So table is in blue. So in order to access anything on your calculator in blue, you have to go ahead and hit the blue key or the second key to go ahead and access that. Now you want to make sure, as is mentioned in the previous area, that you go ahead and have ask highlighted on your independent or x values, and auto on your y values, because that'll just make your life a whole lot easier. And you can type in specific x values and it'll go ahead and calculate the y value for you. All right. And so this is the table that I would go ahead and use to calculate this particular limit as x approaches 1. So what you want to do first is you want to go ahead and try to get this limit from the left. And what you want to do is you want to pick values less than 1, but getting infinitely closer to 1 without exactly equaling it. All right. And then after a couple values, I'm going to go ahead and repeat the process from the other side. So what I want to do is, like, for x to equal to 1, 0.9 is pretty close, right? It's less than 1 and fairly close to that. So I want to go ahead and look at 0.9 first. Right. As if I go ahead and put in 0.9, I get a value of 5.02. All right, that's pretty close to 5, but that's not enough to tell me that the limit is 5. All right, so I want to get a little bit closer to 1. And so I want to get a little closer to 1, so I'm going to do 0.99. Now that's getting really close to 1. That's even closer than 0.9 was. If I go ahead and put that in there, I get 5.0002. That's really, really getting closer to 5. But just to make sure, I want to do at least another value, maybe one more if I'm necessary. I'm going to go ahead and put 0.999 in there. So that's almost exactly one. And I see all of a sudden that I do get 5. All right. So as I can be pretty confident as I approach from the left-hand side that my limit on this function is going to be equal to 5. Now I want to go ahead and repeat it for the right-hand side. And so now I want to get closer and closer to 1, but I want to be on the right-hand side on 1, so just slightly bigger than 1. All right, and I'm going to go ahead and start with 1.1. And if I go ahead and put 1.1 in my table, I get 5.02. That's pretty close to 5, but still not enough to tell me that that limit is going to be the same on the left and from the right. So I'm going to go ahead and get a little closer to 1 from the right-hand side. I'm going to put 1.01. Now notice on this side I'm adding more zeros instead of more 9s because I want to get closer and closer to the actual value of 1. And over here I get 5.0002, which is starting to match what I'm getting on the left-hand side. But I want to do at least one more value. So if I go ahead and put 1.001, now I'm getting really close to 1, I end up with that nice whole number of 5. And so I could go ahead and see that if as the limit approaches 1 of this particular function, I can confidently say that the limit is going to be 5, and the left and right sides are going to go ahead and match. All right, let's look at this guy. So if I have h of x, and it's equal to the square root of x minus 3 and over x minus 3. And I want to find the limit as h of x here approaches 3. Now, notice that 3 in this case is not defined. If I plug 3 into the denominator, I end up with 0, which makes it undefined. So there's not going to be a value at there, but I can go ahead and calculate the limit from the left and from the right, even though that value does actually not exist. Okay, so if I'm putting it into my calculator, what I want to make sure is when I'm putting it in, that when I do that square root of x, I want to make sure that I arrow out of the square root before I put the minus 3, or it's going to keep that minus 3 in the square root, and it's vastly going to change your answer. Right? And I go ahead and I put each piece in parentheses from the top and from the bottom so that I know that the calculator is going to go ahead and calculate that properly. And then I'm going to go ahead and use this table. And so here's the table I'm going to use. I want to get closer and closer to 3, so I'm going to use the same technique as I did above. I'm going to use 2.9, 2.99, 2.999 to approach 3 from the left. And then I'm going to do 3.1, 3.01, and 3.001 from the left-hand side. And this is the table you're most likely going to see in my math lab as you're doing your homework. It's going to be spaced out like this. So kind of get used to the idea that this is going to be your dividing line 3, and you may want to write 3 above there. And you're going to have values getting closer this way and values getting closer this way as opposed to the table that we had above. All right. And now if we go ahead and put in the values, all right, I end up with 12.971, 127, and this value for the left gets bigger and bigger and bigger as the value approaches 3. Now if I do it for the left-hand side, the values get infinitely smaller very quickly as I go ahead and approach 3 from the left-hand side. So in this case, my values on the left-hand side and the right-hand side are not going to match. So therefore, this value does not exist. This side goes to positive infinity. This side goes to negative infinity. So therefore, they're never going to match. This is an asymptote because we know it's not defined at 3, and this limit does.